Let's see next topic in Unit 5, mass storage structure. Okay. So in this mass storage structure, generally we use magnetic disk as a secondary storage. So magnetic disk, and previously we used magnetic tapes, but the most compared with magnetic tapes, magnetic disks are better. Okay. So these magnetic disks provides a bulk of secondary storage. The normal in general, the size of this particular magnetic disk today are 1 TB to 2 TB. Okay, previously it is a few hundreds of GBs will be there. Now currently we are using minimum to minimum 1 TB hard disk. Okay, so magnetic disk or hard disk. This is your hard disk drive, the magnetic disk drive. Okay, so there is a disk platter. See here you can see there is a disk platter, there is a spindle, there is a read write head. This will be our read write head, and this will be our actuator arm and actuator axis and actuator. This is called actuator. Okay, so among these we'll see this particular read write head is a magnetic material, and this disk is also magnetic disk. So each disk platter, okay, so you can see there are multiple disks and multiple heads will be there. There is an arm and multiple heads will be there. Okay, so each disk platter has a flat circular shape like seed. Okay, so common platter diameter will be 1.8 to 3.5. The diameter of this one will be 1.8 to 3.5 inches. Okay, so the two surfaces of platter are covered with magnetic material. So outside and so both sides, it will have both sides. So this side and this side, up and bottom, both having magnetic material. They made up of magnetic material. We store the information by recording it magnetically on the platters. Okay, so there is a read write head. This one, there is a read write head. Okay, files just above the surface of this particular magnetic plate. The heads are attached to disk arm. Okay, so what is here, there are multiple magnetic plates will be there. Okay, there is a disk arm will be there. This arm, okay, there is connect there. So this is a actuator will be there. Okay, so this particular actuator will have a disk arm. This is our disk arm. The edge of this particular arm, there is a magnetic head will be there. Through this magnetic head we will perform operations of read and write. That means we can access the data from this particular magnetic head, and we store the data to this particular magnetic head. Okay, so above this particular service and below this particular service, there is it is made up of magnetic material. So this plate is also made up of magnetic material, and this particular head is also made up of magnetic material. Okay, right. So based on some magnetism principles, the data can be read, the data can be write. Okay, now let's see what are the different parts in that particular plate. Okay, so in this particular disk platter is divided into set of tracks. Set of tracks, that means it can be divided into different tracks. Okay, like this one. Okay, so the tracks are subdivided into sectors. The tracks are subdivided into sectors. Okay, so the set of tracks that are at one arm position makes up a cylinder. So there are multiple platters will be there. Here this particular track, this particular track, this particular track. So there are three tracks that made up one cylinder, because there are three magnetic discs are there. And how many are there? Set of tracks, that is here three magnetic discs. This three will have one particular track, and if there is one more track will be there, this particular track is also belongs to one particular cylinder. So there will be a set of cylinders, there will be a set of cylinders. Okay, so there may be a concentric, thousands of concentric cylinders will be there in a disk drive. Okay, as we discussed about it, in general it will be of one few hundreds of GBs, or currently we are using TB. Minimum size of this particular hard disk or magnetic disk equal to 1 TB. If we use solid state, currently we are using magnetic disk of size 1 TB, minimum 1 TB. Okay, so when the disk is in use, the drive motor spins. So here this one, there is a spindle will be there. The drive motor spins at the high speed. Okay, it will spinning at the high speed, so this disk will be rotated very fast. With how much how many times it will be rotated? It will be rotated in 1 minute. In 1 minute, the drive speed, how many times that disk will be rotated? Either 5400, 7200, 10,000, or 15,000 rotations per minutes. Okay, 1 minute it will be this one. So how much speed the disk is rotated, those that much speed that we can access the data. Okay, so the transfer rate, the definition of transfer rate, the transfer rate at which the data flow between the drive and your computer. The data flow between your drive and computer is called transfer rate. Okay, so we have two times: seek time and rotational latency. Seek time and rotational latency. So what is seek time? Seek time is, it is the amount of time that this particular read write head to move from one to access a block of information. Okay, access a block of information. That means this read write head, if you need 53 cylinder number 53. Okay, so in cylinder there is some particular block will be there, you need to access that particular block. So amount of time this particular read write head to access that particular block inside a cylinder is called seek time. Inside a cylinder is called seek time. When it comes to rotational latency, okay, when it comes to rotational latency, the amount of time this particular disk will be rotated so that you will get to the desired block of data. You will get to the desired block of data is called rotational latency. Okay, so it is a necessary time necessary for desired sector to rotate the disk head. Desired sector to rotate to the disk head. So this disk will be rotated so that you will, this head will point to that particular sector. It is called rotational latency. Okay, so disk can transfer several MBs of data per second. So you can observe that when you copy some particular data from one drive to other drive, C to D, or to some pen drive and etc. To some pen drive and etc. You can see that our entire 1 GB is not copied in 1 second. Okay, so some particular 40 MB or 30 MB or 20 MB, 10 MB data per second will be transferred. Okay, right? So transfer rate will be this one: 20, 30, 40 MB per second. That will be your transfer rate. And seek time and rotational latencies will be considered in several milliseconds. How much time? Several milliseconds. Okay, now there is something called head crash. There is something called head crash. You observe that this particular disk head is not touching this particular platter. They don't touch that particular platter. Okay, so if this disk, there is a magnetism, so this particular read write head is lying above that particular disk head. Lying above that particular disk head, this disk head will not touch this particular platter. If, because this is rotating at very high speed, if this disk head is touches this particular platter, though what, there will be some damage to the disk. There will be some damage to the disk. Okay, so what will happen if the part or portion of the disk, that this particular disk head is touched, then the sectors or tracks, sector or set of sectors or tracks that is touched will be damaged. That is touched will be damaged. Once these sectors or tracks are damaged, we cannot use that particular sectors to store the data. To store the data. Okay, so these sectors which are damaged, we'll usually call it as bad blocks. We'll usually call it as bad blocks. So we cannot store any data onto it. Okay, so let's see, if this particular head touches that particular thing. Okay, so then that the disk will be damaged, so we'll call that particular damage as head crash, because the head damages the some portion or some part of the disk. We'll call that as head crash. Okay, so these head crashes we cannot repair that those particular blocks, so they will not be used further. Okay, and one more thing, this head crash may completely damage the disk. May completely damage the disk. Suppose that if there is 1 TB will be there, it may the head may so for some particular millisecond or 1 second, some particular millisecond, it will touch and it will come out. Okay, so few sectors, so I can say that 4 MB of data, okay, 4 MB of disk space is damaged. But sometimes what will happen, if this disk head touches this particular disk for few milliseconds or few seconds, the entire disk will be damaged. Entire disk will be damaged. So once the disk will be crashed, once the disk will be crashed, you have to replace the disk. You cannot repair that particular disk or nothing will be done. All the data that is stored in that particular disk will be lost. Okay, then we will have a removal disk. Your pen drives, CDs, DVDs, flash drives, all are removal disk. External hard disk, all are removal disk. These removal disks, okay, CDs and DVDs are rotatable. Okay, they will be rotated. But when it comes to pen drives and flash drives, memory cards and etc., they are chips. They are chips. Okay, so a disk drive is attached to a computer by using a set of wires called IO bus. Set of wires called IO bus. Okay, so next one is solid state disk. The current disk that is the current permanent secondary storage disk. Okay, they are new technology storage disk. So this will be your solid state disk. Okay, so solid state disk will have its cache, controller, there is flash memory, and this particular solid state disk doesn't have any rotating parts. Any rotating parts. Okay, there will be no moving parts here. It is simply a chip. It is simply a chip. So there will be no seek time here. There will be no rotational latency here. There will be no seek time and there will be no rotational latency. So if there is no seek time and rotational latency, we can say that there is no head crash. That means there is no head crash. So the data may not be, the data will be available for a longest period of time, and there is no head crash. So that the data will be present in that particular blocks. There is no head crash, so there is no chance of bad locks. Okay, there is no concept of bad locks. Here there is no seek time and there is no latency time. So speed will be more. The speed of this particular solid state disk as compared to your magnetic disk, the speed will be more. Okay, so the reliability, when it comes to reliability, that means the data, there is a problem of data loss in hard disk, but there is because of that particular disk crash or head crash. Okay, disk crash or head crash, here there is no such type of data loss, so the reliability will be high. So and when it comes to power consumption, ssds are just chips which will take less power as compared to your hard disk. Okay, right, next. Now, magnetic disk drives are addressed to as 1D arrays. Okay, 1D arrays of logical blocks. The logical blocks are smallest unit of transfer. The size of this logical blocks is either 512 or 1024 bytes. These 1D array logical blocks are mapped onto sectors of disk sequentially. So this is sector, this is cylinder, and these are tracks. Okay, so sector 0 is the first sector of the first track on the outermost cylinder. That means this particular track is the outermost track and the first sector is our sector 0. So it will be uh, the mapping proceeds in order to through this particular track to inner track, this particular track to inner track, this particular track to inner track. So that when it compares, the number of sectors on the outermost track will be greater than the sectors of the innermost track. Okay, so the mapping proceeds through the track, then through the innermost tracks, then to the rest of the tracks, so that the cylinders of outermost to innermost cylinder. Okay, so this mapping converts one logical block number into what is the track. Suppose the track number 8. Okay, then sector 9, track number 8, sector 9, then cylinder number 58. So cylinder 58. Okay, so a logical block, suppose that 250 something will be there, this may be converted into this one, this may be converted into this one. So a mapping of logical block into disk address that consisting of a cylinder number, a track number, and a sector number. Okay, so this is how we can convert a logical address, a logical block address, to the disk address. Okay,